In today's class, we are going to learn about the application software. So which is related to these programming languages. And in today's class, we are going to mainly focus on these low-level programming languages. Okay. Firstly, let's get a review. So do you remember this figure? We talked about this figure in our first class. A computing system is like an onion, consists of many layers, right? So from the inner to the outside. In the previous chapter 2 and 3, we discussed about the basic information necessary to understand a computing system, including the number systems like binary, octal, hexadecimal, right? And also how to represent different types of information in a system, in a computing system. That's the information layer in the very middle of this onion. And then we covered the hardware, right? Hardware components of the computer, and including the volume architecture, which is related in these hardware layers. And this knowledge, in fact, help us understand what is a computer system consists of. So from here, from today's class, we turn to know how to use a computer system. Okay, so in today's class, we will get to know about this programming layer. In the third layer, the programming layer, and begin with the machine language. So the first program, in fact, it was written in 1951, and it was written in the binary digit. Okay, so the first program, as we say, the software is in fact some kind of a program. And the program is what we told the computer how to do the instructions. We told the computer a series of instructions about how to do and what to do in one step by one step, in a sequence order, okay? And so in the very first beginning, in the 1951, the first program was written, and which was in the binary digits. We have said everything in the computer, including the instructions, are designed in the binary strings. So we say any language was written in the binary string format. We call it the machine language. So the machine language has several properties. Firstly, we say it is the lowest level programming language, lowest level. In the very first beginning, I said today we are going to learn about the low-level programming language. So corresponding to it, we are going to have high-level programming language. Okay, so low-level, it represents, it is much more convenient for the computer or the machine to understand, but it is quite difficult for the human being to understand. So we call it very low-level programming language. For example, today we are going to learn the machine language is one kind of low-level programming language. And among all the low-level programming languages, it is the lowest level programming language. Okay. Also, like assembly language is also a low-level programming language. Okay, so assembly language is a little bit higher than the machine language, which was directly written in these binary strings, which is a little bit higher compared to the machine language. it was written in some English words to more easier for our human being to understand. But both of them we call them low-level programming language. And corresponding to it, we have high-level programming languages. For example, the C programming language, the C++ programming language, or Java programming language, or Python programming language. Both of them we say are high-level programming language, which is much convenient for our human beings to understand, but it cannot be directly understood by the machine. So today we are going to learn about the programming language and also like the algorithm, like the pseudocode, all these programming contents. Today we are start from this low programming language, which we mean the machine language. And in the later class, we are going to learn about some higher programming languages. Also, we are going to learn some data structure, some algorithm, and some programming approaches or design properties, which help us to design some software to use such kind of computer to accomplish a series of tasks, specific tasks. So that we are going to learn in our later classes, but we are not going very further detail about the detailed components about all these algorithm or data structure or programming. In our next semester, we are going to have a course named as C programming language, which may also lectured by me. So in that course, we are going to have 64 hours for that course to learn about the C programming language. And we are going to learn more detail how to in fact we can write a program so that the computer can execute and it can obtain some results. That would be much more detailed. But in this course, in today's class and our further there are a few classes, we do not go to very further about these implementation details. We just learn about the concept. We get to know about the concept of how does a programming language looks like and what's the concept, the underlying concept behind them, without some details. That what we also mentioned in our first class, that the abstraction, okay, the concept of abstraction. Okay, so let's talk move back to our machine language. So one of the most first property that it is the lowest level programming language, and it is all written in these binary strings. Okay, so the second most important property that it is in fact built into the machine. Okay, so it is built into the machine. So that means for each computer, for each different machine, it could be totally different, since their instruction may not be shared. The instruction may be different. So the machine language was built into the machine. Okay. So so in the following classes, we are going to learn about what the computer can operate. And we use a PIP-8 virtual machine as an example to learn about the machine language, to learn about the how the machine language works and how does it represent. So we also have to learn about the instruction format. As I have said, for each different machine, the instruction may be totally different. And all the machine language or the programming are based on the instructions built into this machine. So we are going to learn about the instruction format to use this PIP-8 virtual machine as an example. And we are also going to take a series of programs shown as an example. And our today's assignment will also relate to this. Then this is about the machine language, the lowest level programming language. Then we are going to learn about the assembly language. Okay, assembly language, which I have said is also another low-level programming language. So the assembly language, it uses a combination of letters, to represent a machine language instruction. Okay, so in the computer, in fact, the programs written in this assembly language should be translated into the machine language so that the machine can understand. So the machine language is the only language that machine can understand. Okay, it's the only language a machine can understand. Okay. So any high-level language or even some low-level language like assembly language, they need a translator. They need a translator to translate them into the machine language, which is also we call it a system software. Okay, such kind of translator. For the assembly language, we call them assembler. Okay. And then we are going to talk about the fifth generation about this software. Okay, the fifth generation. What's the development of the software from the first generation to today? How does it develop? So in order to understand about the software, we need to know about algorithm. So we say any software or program, it equals algorithm plus a data structure. Okay, since algorithm represents, you tell the computer what to do and how to do it in one step by one step. And the data structure represents the data you need to operate or need to access. How does they constructed? In what kind of manner? So combine the algorithm and data structure together, we can create software. So in order to get to know about the software more easier, we need to learn about the concept of the algorithm. So how we represent the algorithm or how we express the algorithm. In fact, we are going to introduce two approaches. One we said it's a pseudocode, another we say it's the flowchart. So the pseudocode, you can say it is also a code, okay? Like the programming, it is some kind of code, but it's not real code, it's a pseudocode. It means it doesn't follow or obey the instructions or the rules strictly defined by any programming language. Okay, so it's some kind of code, but it doesn't restrictly obey all the rules defined by any programming language. So we call it pseudocode. But by reading such kind of pseudocode, our human beings can understand the algorithm. Okay, so it just helps us to express and understand the algorithm. So it has a format similar like the code. And then flowchart is different from the pseudocode, although it is also a way to express the algorithm, but the flowchart is it's a chart, right? So it's some kind of figure, okay? So we use some shapes, we use some symbols, and we use some arrows to represent the flow defined in this algorithm, okay? Okay, so we use arrows to define a flow. So in this algorithm, one step by one step. So this is the contents would cover in today's class. So we of course have some chapter goals. We want to understand firstly, and we should can list the operation that a computer can perform, right? We need to describe what's the important features in such kind of a virtual machine, and we learn about the instruction specifier, operand specifier, and operation code in these instructions. And we learn about two addressing mode, immediate addressing and direct addressing mode. And we are going to write a very simple machine language program and learn about the machine language and assembly language and know the